One of the nice things about Postgres is it actually has a fairly extensive encryption package. And you go, why do I need encryption? Well, there's passwords. For instance, doing your encryption right is pretty important. Ashley Madison lost a copy of their database because a disgruntled employee let a copy of the database itself, a backup, was sent to other people. And whether or not that's right, it's going to happen to some of you sooner or later in database. And here's what you do about passwords. Now, they did it wrong. The password scheme that this uses is a thing called, it's labeled as BF, okay, right here. But it is called, I don't know now. In any case, the BF password scheme, you'd have to look it up in the documentation as to what that stands for, is a password scheme that is designed specifically for doing passwords and is slow. That's not the one that Ashley Madison used. They used a different one that requires that you set a critical parameter based on the speed of computers, not just the computer you're running on, but it redoes this hash over and over a certain number of times. And these days, that number that you're supposed to use for that is somewhere around 100,000 times that it reruns the hash. The BF system doesn't require that, but this other one does. Ashley Madison set it to 3, and 3 was not enough. So consequently, they lost all the passwords, I think around 40 million in their entire database, as I recall. I might be wrong on that number. But consequently, everyone that had an account lost their passwords. If you had an account, you had to reset it. And this caused a rash of interesting results like divorces. Ashley Madison is a site for married people to cheat on their spouse. So, no comment as to whether or not that's a good thing to have for a website or good to be a member of or not. But that's up to you to form your own opinion. But in any case, the fact is that right after marriage was invented, cheating on marriage was invented, so we have a site for it, as do we have sites for everything else that you can possibly think of and a few you can't possibly think of. So, encrypting your passwords. And I'm going to walk you through what the steps are. The first one is creating an extension PG Crypto. And we'll run that and create that extension. You have to have that if you want to use the cryptography package. And once you have created that, you probably had that before, we'll create a set of example users to walk through how this works. The set of users, you notice, has a password, text not null, but what we're actually going to put in the password is not the person's password. We're going to store a hash of the password. The hash is specifically a means by which to go from what you have to a representation that you can't go the other direction. So we created this table. And once we create the table, we want to sit here and create a function and a trigger on that table that will allow us to save this as an encrypted password with a thing called salt. Salt is a means by which a person prevents multiple users from having the same password and consequently being able to identify it together, or a means by which to prevent factorization of passwords. So we've put a trigger on there that when we insert this, it inserts or updates the password in an encrypted fashion. So it's on both insert or update. It runs this. And in both cases, it takes the password, generates the salt, and encrypts the password. So you just set it as a regular value, but when it gets saved as an encrypted value. So let's actually give this a test and see what happens with that trigger, make certain it actually works. All right, we inserted my very bad password. Trust me, that's not one that I use. And now we're able to go back and select from this based on this particular user's email, the password that is stored in there. And notice that when I do the select, I just use straight password, and then I say encrypt this, and I pass the second parameter to crypt as the password itself, because the first part of the password it saves is the salt, and it has to have that to decrypt it. And with any luck, yes, we will find that it got an ID of 1, which means that it actually selected back that row and said, yes, your password matched. Now, if we actually go and just select star from this table, let's do that once. Let's take a look at what that password looks like. We won't do any encryption. We'll just select it and run it. You'll see that the password that I put in, it now looks something like this. And I happen to know something about the internals of the package. That dot is the marker that it uses between the salt and the password. So this is actually the encrypted value of the password out here, which looks nothing like the original password. So if you were to lose your database, you wouldn't actually lose very much, at least not in the password department. You might lose a lot in other places. Now, to make this practical, we'd really like to have some sort of a function that allows us to quickly determine whether or not the password is correct. And so we'll build a function that we can select from that will tell us about doing logins. And we'll run it a couple times here so that we can actually see what the results are. And when we gave it a good password, it said that it was a valid user. When we gave it a bad password, as in something is different, it says incorrect username or password. And we should probably run more tests on that to validate it. But that gives you an idea of how to do a login system in the database with encrypted passwords. And I actually clicked the grade button, so I got my points for this. And that's kind of how easy it is to protect your passwords in Postgres. So you're building an application, you want to have some data that isn't going to leak, okay? It's really very easy to do. It does not take a lot of code. We've added a trigger and a stored procedure, and we're done. That's like good stuff. This means that when you do backups, you don't have to worry about somebody poking into your backup or your log files or poking into some other thing and being able to get the passwords themselves. That doesn't protect your whole database. That's not everything. But that's one important piece.